In this video, we will briefly discuss recording measurement. We will define significant figures. We will learn rules for determining number of significant figures in a measurement. We will learn rules for rounding, and finally, at the end, we will see rules for handling significant figures while doing math. So let's have a brief review of recording measurement before we learn the rules to count significant figures. To see recording measurement topic in detail, you can watch the video provided in the description link below. The rule while taking measurement is that we always take one estimated digit, and this estimated digit is the last digit. The digit prior to the estimate is always a mark on the device. So you can see this on this ruler, the first ruler that we have. Each line is worth 10 centimeter. So when you record the length using this ruler for this crayon, you will estimate to one's place. And the estimate, if I take the reading, it will be like 4 or 5 centimeter. And you can see I have my reading only up to one's place. On the second ruler, each line is worth 1 centimeter, and the length of crayon is longer than 4 centimeter but less than 5 centimeter. So an appropriate reading for this would be either 4.2 or 4.3 centimeter. And in this measurement, my 4 centimeter is known digit. I took it from this mark, and this 0.2 and 0.3 is my estimate. The third ruler that I have, it has the same marking as the second ruler in zero point 0.1 centimeters, but the length of crayon is exactly on 4 centimeter line. In this case, you will add a 0 as your estimate, and the measurement will be 4.0 centimeter. So we always make an estimate, and that estimate is after the reading or after the number that you're taking from this mark on the device. On this last ruler, each line is worth 0.1 centimeter, and length of the crayon, you can see, is longer than 4.2 but less than 4.3 centimeter. So the appropriate reading for this would be 4.25 or 4.24 centimeter. In this measurement, 4.2 is my known number because I took it from the mark on the device, and this 0.4 and zero point 0.5 is my estimated number. Now we have these measurements from different devices, and all these measurements have a certain number of significant figures or the values that can tell you about the precision of the measuring device. The estimated value that we are taking, the last digit, is also a significant number because it helps define the precision of the device being used to measure. Okay, so let's look at the topic significant digit. Significant figures are also sometimes called significant digits or significant figures. Are the numbers of digits in a measurement that indicate the degree of precision of that measurement. So in other words, these are the numbers that are within the ability of the measuring device to precisely measure, and the measurement with more precise digits or more significant digits is called more precise. So if you look at the example that we took the measurements in the last slide, we have this ruler, each line is worth 10 centimeter. This ruler, each line is worth 0.1 centimeter. And the third device or the third ruler, each line is, sorry, the second one is each. Let's look at our topic, significant figures. Significant figures are also sometimes called significant digits or sig figs in short. These are the numbers of digits in a measurement that indicate the degree of precision of that measurement. In other words, these are the numbers that are within the ability of the measuring device to precisely measure, and a measurement with more significant digit is more precise. So here we have some measurements from different devices, and all of these measurements have certain number of significant figures or values that tell you about the precision of the measuring device. So you can see the first measuring device that we have, each line is worth 10 centimeter. The second one is each line worth 1 centimeter, and the third one is each line worth zero point 0.1 centimeter. So this third ruler, or the third device that we have, is more precise compared to these two devices that we have. And this estimated value that we are taking, this is also significant because it helps define the precision of the device being used to measure. Okay, our next topic is counting significant digit. So there are some rules that will help us to determine the number of significant digits. And if a measurement has already been made and provided, then we can determine how many sig figs or significant digits are present by following some simple rules. And you guys will see all those rules in next few slides. So the first rule is all non-zero numbers are significant. So what does that mean? It means that any number from 1 through 9 are all significant all the time. You have example here 2.38. All these numbers are non-zero numbers. So all of these numbers are significant. So this 2.38 have three significant figures. 25 is also non-zero digits, so it has two significant figures. The second rule to determine the number of sig fig is that zeros between non-zero numbers or captive zeros are significant. So a captive zero is a zero which is trapped between two non-zero numbers. And here is the example. So 6 is a non-zero number, 7 is a non-zero number, and 0 is in between these two non-zero numbers. So it is a captive zero, or it is sometimes called a sandwich zero. So this will always be significant. So in 6.07, we have three significant figures. And same is for this captive zero. This is significant. So 30.1 have three significant figures. The next rule that we have is related to leading zeros. Leading zeros are zeros. Those are before the first non-zero digit. These zeros are never significant. They are generally found in numbers that are less than 1, right? And known as placeholders, as they do not add any precision to the measurement. So example that I have here is 0.0025. So these leading zeros are just placeholder. They are not significant. And this measurement has only two significant numbers. In the next example, these leading zeros are not significant, but you can see that we have one captive or sandwich zero. So in this measurement, we have three significant figures. 0.03, it has leading zeros which are not significant, and after leading zeros, this 3 is the only one number, non-zero number. So this is so this measurement has one significant figures. The next rule that we have is related to trailing zeros. So trailing zeros after a number are not significant unless there is a decimal point. So trailing zeros are not significant unless there is a decimal point, and this is a big caveat here that they won't be significant unless there is a decimal point. Okay, I think this needs to record it. Okay, so the fourth rule that we have to determine a number of significant figures is that trailing zeros after a number are not significant unless there is a decimal point. So this is a big caveat here, unless there is a decimal point. So consider these examples that I have, 250, and it has a decimal here, and 250.0, it also has a decimal point. So with this decimal point, the trailing zero is significant. So this measurement have three significant figures, and this has four significant figures. Also, it doesn't really matter where this decimal point is. The decimal point can be really in the beginning, means that the measurement can be 0.250. Even with that, it will be three significant figures. Okay, so the last rule to determine the number of sig fig is for the trailing zeros in a whole number with no decimal point. So if there is no decimal point in a number, the trailing zeros may or may not be significant depending on where uncertainty lies. Let's look at the example here. Writing 3400 is okay if it is an exact number. However, if the number is a measurement, then leaving out the decimal point will increase ambiguity or will create the ambiguity. As without decimal point, there are three ways to interpret. It could be interpreted as 3400 plus minus 1, meaning that both zeros are significant zeros, or plus minus 10, meaning that 0 at the tens place is a significant zero and 0 at the ones place is just a placeholder. Or it can be interpreted as plus minus 100, means both zeros are just the placeholder and it has only two significant numbers, which is 3 and 4. And because chemistry is a quantitative science, chemists must make sure that the numbers that they write communicate, have a clear meaning and are not ambiguous like the examples we have here. Okay, let's look at some examples here and indicate the number of significant figures in these before we wrap up this topic. So the first measurement that I have is 12.60. This zero is a trailing zero with a decimal point, so this will be counted as significant number. So this measurement have four significant numbers. The next one, we have all non-zero numbers, so this will have three significant numbers. The third example, we have many leading zeros, and leading zeros are never significant, so this measurement have only one significant number. In the next example, we have many captive zeros or sandwich zeros, and those captive or sandwich zeros are always significant. So in this measurement, we have six significant numbers. This next example, 125 feet, all are non-zero numbers, so this will be all three numbers are significant. The next example, we have a trailing zero, but there's a decimal point, so trailing zero with a decimal point is significant. So in this measurement, we have four sig figs. The next measurement, we have five sig figs. These two trailing zeros are significant. The last measurement, 2200, is without a decimal point. So this is where we are not sure how many sig figs it have. For sure we know that it has two sig fig, but it may be more than two, or it can be three or four if there is any extra information given. Okay. Now let's look at our next topic, which is rounding rules. So it is often necessary to round numbers after we perform calculations. And sometimes we have to round our answer to show proper number of significant numbers. So we have some rules that we will see. So the first rule, first rounding rule is that if the last digit to be kept is followed by a number less than 5, then round down by dropping all the digits to the right of it. For example, We have this number we have this number 54.654873. If we have to round this number to four significant digits, those four significant digits will be up to this, right? We have one, two, three, four. So if we have to round it to four significant digit, it will be up to this. You will be looking at the number that is right after this last digit to be kept. And you can see that the last digit to be kept is this, and the number after this is less than 5. So after rounding, your answer will be 54.65. You will just drop these numbers here. Rounding rule is that if the last digit to be kept is followed by a 5 and no other non-zero digit, then round up by adding 1 if the last digit to be kept is odd, but do not add 1 if the last digit to be kept is even. So here I have example 5.8750, and if we have to round this to three significant digits, so those three significant digits will be 5, 8, and 7. This is our three significant digits. So if I have to round it up to this, I will look at the number that is right after that. So it is 5 and no other non-zero number. I have 0 but no other non-zero number. So what I will do is I will round up because my last digit to be kept is odd, and the answer will be 5.88. So we did the rounding up based on the rule that if the last digit to be kept is odd, then add 1. The next example you can see here is 6.3650. And if this has to be rounded to three significant digits, so those three significant digits will be 6.36. And the number after the last digit to be kept is 5 and no other non-zero digits, then the rounding to 3 sig fig will be 6.36. And here we didn't round up as the last digit to be kept was the even number. Okay. The fourth and the last rounding rule is that if the last digit to be kept is followed by 5 and non-zero digits, then round up by adding 1. So example for this, I have 32.4521. And if we have to round this up to three significant digits, so those three significant digits will be 32.4. Um, s- and the and if I look at the number after the last digit to be kept is 5, and there are more non-zero numbers, then what I will do is I will round up to this number, and my answer will be 32.5. Okay. Our next topic is rules for handling significant figures while doing math. So before we look at those rules, let's have a quick review of exact numbers. Exact numbers are numbers that came from some counting or definition or some universally defined numbers and are not from some measurement. These numbers have infinite number of significant figures. An example of this is defined numbers such as 1 foot equals 12 inches. There are exactly 12 inches in 1 foot, and if a number is exact, it means that it doesn't affect the accuracy of a calculation nor the precision of the expression. Some more examples I have are there are 100 years in a century, or 7 days in a week, or two molecules of hydrogen react with one molecule of oxygen to form two molecules of water. All these numbers are exact numbers, and they do not affect the accuracy of a calculation and do not affect the precision as well. You might be curious why there is so much focus on sig fig in chemistry, but they are not so important when solving problems in our math class. The answer for that is math classes do not deal with measured values. As a result, all of the numbers are considered to be infinitely precise. But in chemistry or in science, we deal with measurements, so we have to be careful when using those measurements for mathematic operation. We need to remember that all the measurements that we have some degree of uncertainty in it. And when we are doing math with these numbers, we must only use the numbers that are meaningful. Significant figures when doing math. In mathematical operations involving significant figures, the answer is reported in such a way that it reflects the reliability of the least precise operation. An answer cannot be more precise than the least precise number used in the calculation. So we have separate rules for multiplication, division, and addition, subtraction, and we will look at those rules one by one. Rule for multiplication and division is when you multiply or divide, determine the number of smallest number of sig figs in each number being multiplied or divided. The smallest number of significant figure in these values is the number of significant figures allowed in the answer. That is our first step, that we have to determine the number of sig figs in the numbers or measurements that we are multiplying or divide. Once we are done that, the next step is perform the arithmetic on your calculator, the simple calculation. And then the third is perform rounding to the correct number of sig figs. And we have learned the rounding rules as well. Okay. So here I have example. We have to perform calculation and show our answer to the correct number of sig fig. So remember, the first step is to determine the number of significant figures in each number being multiplied or divided. So here we have a multiplication. In this measurement, these two zeros are leading zeros. They are never significant. So the first measurement have two significant numbers, and this 2.30, the trailing zero after a decimal or with a decimal, is always significant. So three significant figures in this measurement and two significant figures in this measurement. And remember that our answer can have the smallest or the least number of sig figs. So if we are identifying 2 as a small number, our answer will have only two significant numbers. So with the first step, I identified that we have two sig figs in this measurement and three sig figs in the second one. The next step is I will just punch in these numbers in the calculator and I have my answer 0.0828. And you can see that in this measurement, certainly there are more than two sig figs. And more sig figs means we are saying that this answer is more precise than one of the device we got the reading from, right? This device was only precise up to two sig fig, and we have three sig figs here. So we are going to round it to the two significant figures, and our two significant figures will be this 8 and 2. Based on the rounding rule, if the last digit to be kept is followed by a number which is greater than 5, we will add 1 to this last digit to be kept, and your answer after rounding will be 0.083. Okay. We can also express this answer in scientific notation, and in the next lecture you will learn how to convert a normal notation to a scientific notation. Okay. The second rule that we have for doing math is for addition and subtraction. Rule for addition and subtraction is different than the rule for multiplication and division. Here you have to determine the number of decimal places. Decimal places means digits after the decimal point. So you will determine those decimal places in each number being added or subtracted. And then the smallest number of decimal place in each value is the number of decimal place allowed in the answer. Then you perform the arithmetic, and after that you will be performing the rounding to the correct number of decimal place. Let's look at the example here. In this example, we have to perform calculation and express our answer to the correct number of decimal places. The rule for addition and subtraction is we have to look for the number of decimal place, and the smallest number of decimal place is what we will show in our answer. So this first measurement that we have 2 decimal place here, and in this second measurement we have 4 decimal place. So 4 decimal place here and 2 decimal place here. So that is my first step to identify number of decimal places. The next step is I will just perform my simple arithmetic. I just added these 2 numbers, and my answer on the calculator is 7.3256. Now, based on the rule, I have to round this answer up to the lowest number of decimal place, which in this example is 2 decimal place. So if I identify where my 2 decimal place is, my 2 decimal places are up to this point, means I have to round my answer up to this point. So if I round it and this 2 is the last digit to be keep, after this 2 I have 5 and some non-zero number. So based on the rounding rule, I will be doing round up here, and my final answer is going to be 7.33. Here I want to caution you about that the rules for adding and subtracting are different from the multiplying and dividing. A very common student error is to swap the 2 sets of rules, or another common error is to use just one rule for both types of operation. So you really have to remember that the 2 rules are different. In multiplication and division, we'll look for the number of significant figures. And in adding, subtracting, we look for the number of decimal places. And then the smallest number of sig fig or decimal place is what we show in our answer. Now let's look at what to do or how to handle sig figs if you have a problem where you have both multiplication, division, and addition, subtraction in the same problem. So what you will do is you will perform whatever step you have to perform first, like you will perform addition, subtraction step. You will note down the correct number of decimal places that the answer would have, but do not perform the rounding. And then you will perform the next step, which might be the multiplication division step. And same thing, you will note down the correct number of sig fig allowed in that answer, but you are not going to perform the actual rounding. And the rounding will be at the end to the correct number of sig fig. The reason we are not rounding at the step number 1 and 2 is because if you round at every step and then you are rounding at the end as well, then your final answer will be very far away from the true or accurate answer. There will be too much rounding. So we are not going to round at every step. Let's look at the example here. This example have both addition and division in the same problem. So it will be a multi-step problem. So the first step that I'm going to do is adding these 2 numbers. And when I'm going to add these 2 numbers, the first thing I will do is I will find how many number of decimal places I have in each of these measurement. So my first measurement have 1 decimal place, and the second have 3 decimal places. The next thing I will do is I'll just add these numbers on a calculator, and I have my answer. Now, normally, if it is just a one-step problem, I will just go ahead and round this to the lowest number of decimal place, which is 1. But since it is a multi-step problem, I will not round at this step, but I would like to know if there is a rounding needed, then how many decimal places I will show, and my answer will be up to this point. So my answer, if I have to round, will be up to 1's place. So what I'm going to do is just have a underline here, but not perform the actual rounding. After this, the next step that I will do is I will be performing division. And for division, I will use the whole number that I have on my calculator in the previous step. I'm not using the rounded one, 18.6. I'm using the whole number and dividing it by 12.02. And after that, I have this answer on my calculator and I just wrote it down. Now to determine the correct number of sig fig here, because this step is a division step, right? Division is what I'm performing here. I will look for the number of significant figures. Instead of looking at the significant figure in this whole number, I will be looking at the significant figure only in this underline area. And in this underline area, my sig fig is 3 for this measurement and 4 for this measurement. The reason I'm looking at only under this underline area is because this is what if I had to round for this previous step, right? I didn't round it because I don't want to do too much rounding, but I need to know that this is the number that I could get from this previous step, right? So here I have 3 significant figures and here I have 4 significant figure. If I have to do rounding for this answer, I will be rounding it up to 3 significant figures, which is up to this number. And then I will look at the number that is right after this 5, and the number right after this 5 is less than 5. So I will just drop these numbers at the right and my answer will be 1.55.